everybody on? Yeah, everybody should be on this page right here. Testing question. A new mask? Yes, they're right up here. Okay, go ahead. I have a question. Okay, there's nothing we can do about it, though. You're going to have to just wait until it falls out. Grace. Stop putting your hands in your mouth, though, because you have to wash them. That's okay. That means we'll probably go through it pretty quickly.
How do you open it?
And here we go. Let me go ahead.
How do you open that?
I'll get it.
It's childproof.
I should not hear any talking right now, though.
My sister will open that with scissors.
The donuts can be picked up between, I believe, 8 and 12 today. You have it. Not PM. That means right now. Okay, come on, guys. We need to get started. We're running a little behind today. We still have a spelling test to take later. Go ahead, Briggs. Zoe, question. The cows are a little too big for snakes to eat. Okay, Hester, go sit down. Joel. Okay, so I know some of you guys worked ahead, and that's okay. I'm going to very quickly tell you guys what we're going to do on this work. Then I don't think it's going to take you very long, and we'll go through the entire thing together, okay? There's only 3 pages we're doing today to review from yesterday, for the most part. So let's just take a quick look at it. We've obviously got some guys on the roof right now, so we're going to see a little shaking over here. Okay, but I still do not want people talking out, making sounds. Still in our 3 strikes. If I have to warn any of you more than 3 times, you will get a red point. Okay? I need you guys raising your hands, not speaking over each other, me or Miss Paula. Go ahead. Okay? Rules are the same. Now, this one, you're just finding the missing numbers to create an equivalent fraction. So this is review from even before spring break, right? When we were doing equivalent fractions, this is review from before spring break. Okay? Then, on the second one, now we're into comparing, just like we were doing yesterday. But you're going to notice that sometimes you might see something, some different denominators. We were doing like denominators yesterday. Some of these are different. But, like I said yesterday, do not let the numbers fool you. Look at the pictures too. Those bars are there. The fraction bars are there. The fraction strips, they're there for you to use, okay? So you need to rely on your eyes, the visual, to help you understand what those numbers mean. And then on the third one, same thing, but with circles. You know, I like to use the pizza example. So this is pretty much like that, right? That's it. Those are pepperoni. Should be more pepperoni. That's not very much pepperoni, but these, again, do not let the numbers fool you. Look at the pictures, okay? Because some of these are going to have different denominators, right? But you guys did really well when we did the unlike denominators yesterday in the Kahoot game, so I think you're going to get this. And we're sort of working ahead a little bit, which is good. You guys are going to be a little more advanced in your fractions, okay? So this isn't gonna. I don't think this is gonna take you that long. I will check in with you guys at about 9 or so, and we'll see where you guys are. And as soon as everybody is ready, we will go over it together, okay? But I don't want to go any later than about 9, 10, just depending on where everybody is, okay? Ariana, question. Okay, hold on. Jack, question. Yes. Wait, after breaks. Aiden, question. You didn't hear what I said about what?
When you're talking about the math work, you're too quiet.
What's too quiet?
When you're talking.
I'm too quiet? I'm pretty much yelling. You guys couldn't hear me?
I can hear you. It sounds like you're.
Is it because of the noise ahead? Okay. These are relatively self-explanatory though, okay? I want you to make sure you read the instructions. But one more time, very quickly, and this goes with everything, even the ones that, oh look, I forgot there's another page. No, that's not today. Don't look at it. Don't look at that one. That's April 8th. Don't do that one. Only do the 3 for today. Wow, I almost made you guys do extra work. April 7th, missing numbers. It says find the missing number to create the equivalent fraction. So these are equivalent fractions on this page, okay? Edit. These are equivalent fractions on this page. The second 2 pages are just comparing, just like we did yesterday, okay? So give it a try. And again, I don't want to go past 9:10. I'd like us to all come back around at that time, but we'll see where everybody is in just a little bit, okay? Brewer, go ahead and go. Any questions?
Would you look the alligator things on the one with the bar? Yeah.
On the one with the bar?
Yeah. That's what I was That one.
Yeah, because that's comparing.
Oh.
I apologize if that wasn't clear. Yes.
I'm done then.
You are. Oh, are you? Okay. Yes, you are comparing those, which means you're using the greater than, less than, or equal than symbols. And again, I apologize if that was not clear on that. Schmidt. Question? Briggs. Are you done? Let me see. Let me get a quick hand here. Who is finished with this already? With all 3 pages already? Okay, so we got a few people who finished, and then a few people who have not. Now, I would recommend that you guys study your spelling words. Go ahead. Yes, that one as well. Have you finished it yet? No, you're working on it still? We got 3 pages today, guys. 3 pages today. I recommend studying for the spelling test when you are done with this, and then we'll come back together. Okay? I want to give everybody a little chance to work on this for a little longer. Heston, you have a question? Okay, I'm going to make my way around then. Okay, so let's go over these. Because I think that this area, I think the comparing seems like it's been pretty easy for you guys, but the equivalent fractions seem to still be a challenge. So I want to make sure we're all on the same page with these ones. Can everybody see this pretty well? Do I need to make it a little bit bigger? Pretty good? I can make it a little bigger now. Okay. So again, you're finding the missing number to create an equivalent fraction. What does equivalent mean again? What does equivalent mean again, Teva? Equal. That's right, equal. So even though they might not look the same because they might have different denominators, and they're going to have different numerators as well, they're going to be equal. But remember, if you need to, you can always draw out pictures as well, even to find equivalent fractions. So in this case, the halves, I think, are pretty easy for you guys. Most of you got the halves. I think it's when we get into the others that things get a little bit more complicated. Okay? Yes, I want everybody to have this out. Computers away, please. And books and everything else that you might have in your hands away, please. Thank you. So in this case, we have the half, and we have one that's divided into 4. So one has 2 parts, one has 4 parts, right? So look, 1/2. And let's look at the one that's in 4th. What could you color in to make that circle that's divided into 4th? How many do you need to color in, Heston, to make that equal? 2 of them. And then look, guys. They look exactly the same, do they not? They match up. That's exactly right. One just has 4 parts, one has 2 parts. Now, the other way to do this, and this is the part I really want you guys to pay attention to, because we talked about it, and you really need to do it for the other ones, like this. Halves are easy. Halves are the easiest ones, because the trick is, what's half of 4? What's half of 4? Exactly. And you're going to see that with every single half, right? Like right here. What's half of 6? 3. What's half of 6?
3.
Easy, right? 1/2 equals 3 is 6. So 3 is half of 6. Now, Where it gets a little bit more complicated, though, is when you get to the ones that are not halves, like a third here or a fourth over there, right? But you can do the same thing with the halves that you do with these. You just have to look for the common factor, right? You remember the common factors? Thumbs up if you guys remember common factors. Okay, so look. What you're really looking for is how can you get from 3 to 6 using multiplication? How can you get from 3 to 6 using multiplication? Jed?
2 times 2 and 1 times 1 times 2.
That's right, because anything you do to the bottom, you have to do the top as well, right? Anything you're doing to the denominator, you're doing to the numerator too. So 3 times 2 equals 6, and 1 times 2 equals what? What does 1 times 2 equal?
2.
There you go. So 1/3 and 2/6 are equivalent fractions. Does that make sense? Now remember, you're doing the same thing here too. How can you get from 2 to 4? Andrew, how do you get from 2 to 4? 2 times what? That's right. 2 times 2 equals 4. So then 1 times what? That's right. 1 times 2 equals 2. So you're still using common factors there as well. You're looking for the greatest common factor, the factor that you can use. Where did that sound just come from? Okay. Not appropriate. 1/4 and 4/8. Let's look at that one. I know that one looks a little weird, right? Allie, what's our answer for 1/4 and 4/8? What is it? 4 times what? That's right. So what is 1 times 2?
2.
That's right. So 1/4 is the same as 2/8. So for those of you who are asking me questions about this, are you paying attention? Because you should be. This is how you get these answers. Can't just throw in numbers, can't just make it up. There's a way to do it. We're looking for how can you get from 4 to 8? Well, 4 times 2. And if you know you can use 4 times 2 to get to 8, that means you are definitely going to be multiplying that top number by the same factor, right? That's why it's a common factor. Andrew? Yes, go ahead. See, we did the same thing here with this 1/2, right? 2 to 6. 2 times 3 equals 6. 1 times 3 equals 3. Does that make sense, guys? Add off, please. Put it down on your bed. Okay. 1/2. Now we're in the halves again. Halves are easy, guys. 1/2 is equivalent to what, Talon? Yes, you can. Guys, 1/2 is equivalent to what? Allie? That's right. 4/8. Because what's half of 8? Guys, what's half of 8?
4.
That's right. That's why this one's so easy, right? But again, you can do it with a common factor. What times 2? What times 2 is 8? What times 2 is 8, Schmidt? That's right. 2 times 4 equals 8. 1 times 4 equals 4. Same thing, common factor. You can use it on there as well. The halves are just a little bit easier. But what about this one? What about this one here? 2/3 equals how many 6? 2/3 equals how many 6, Ariana? That's right, because, Ali, what times 3 equals 2? 2. That's right. 3 times 2. What times 3 equals 2? I meant what times 3 equals 6? I gave you the answer, technically. 3 times 2 equals 6, which also means that 2 times 2 equals 4. You guys see the pattern? You see what we're doing? Do the common factors make sense? Yes, some thumbs up. Good. Some sideways thumbs. These are going to take a little bit more practice, but that's why you guys have to pay attention. It's also why I handed you your name tags telling yours is on the ground. Because you will have to use multiplication for some of these. Okay? Really for all of them. Now, the other thing is, I noticed some of you guys not noticing that on your paper. Remember how I always say to you, don't make your lives more difficult? Yeah. Well, you should notice on here that there are some duplicates. Right? There are some duplicates. Like, for instance, this problem here looks like the same one down there to me. So automatically, you guys should already see that this is the same one. Ariana, what's our answer on this one? That's right. And there's another one. What's another one? That's right. You're right. Because there's 1/2 and 3/6 right here. And down here. All they did was they wanted you to fill in a different missing number. Sometimes it's the numerator, sometimes it's the denominator. Which means that this one is also 3/6. Okay? So, don't let them fool you, okay? But make your lives easier by reading the entire page and paying attention, okay? What about this one? 3/4 equals what over 8? Anybody who hasn't answered one in a little bit? Come on. Briggs. 3/4 equals how many 8s? Are you sure about that? Can you get from 3 to 7? You sure? Guys, look for a common factor. Briggs, what times 4 equals 8? 2. So what should I multiply the numerator by?
2.
That's right. Whatever you do to the bottom, you're doing to the top. So what is 3 times 2, Briggs?
6.
That's right. So 3/4 equals 6/8. Does that make sense, guys? Again, we found a common factor. Now, last one. Oh, I hope everybody got this one. 3/3 equals what now, guys?
1/2.
That's right. So if 3/3 equals 1/2, then what do you have to have here?
5.
That's right. Because all of these equal 1. Good. Andrew. Good. So guys, it looks to me like we're going to need a little more practice on the equivalent fractions, so we'll get there. I think the comparing fractions might be a little easier. But another thing I noticed, so let's look at those, is that some of you are making your lives more difficult by not paying attention to the drawings. Do not get fooled by the denominator. Okay? Just because that 4 is greater than the 2 does not mean that that fraction is greater. That's why they have them drawn out. Our holes are the same shape, the same size, right? All of our holes are the same size. These two right here, 1/2 and 1/4. But look where the shading is, guys. Look at the shading. And remember that the denominator stands for how many parts you cut the hole into. So my example yesterday, if these are Kit Kats, or for Tabitha, she doesn't like Kit Kats, something else like a Twix. Or like one of those bar donuts. Maybe that's more for me. Let's say you've got something long like that. You cut it up. 4 parts. You've got more parts, but each part is smaller, right? So if I were to say 1/4 or 1/2, which is greater? 1/4 or 1/2?
1/2. 1/2.
1/2 is greater. Plus you can see it, guys, right? Look at the picture. Which one has more shading? The 1/2, right? What about the second one, though? 1/3 and 2/3. These are like denominators, so they should be pretty easy. We were doing these yesterday. Sellers.
Can I answer 2?
I want you to answer this one for me.
2/3.
2/3 is greater. That's right. 2/3 is greater. And that's easy because they're like denominators, right? So that makes it a little bit easier. But What about with one like this one, though? One of those is divided into 8 parts. One's only divided into 4 parts. Andrew, what's our answer? 3/4 or 3/8? Which one's greater? 3/4 is greater. And guys, when in doubt, count them. Count them. See which one you're looking at. 1, 2, 3, 4. And remember, your denominator will always mean the number of parts that your whole is cut into. That's what the denominator is. It's just how many parts you cut it into. That's it.
Next one is 36.
It's 3/6. You're right. And again, those are like denominators, so they're a little bit easier because both of your wholes are cut into the same number of parts. So it's kind of easy to see that 3 is bigger than 2, right? So,
Next one is 2/4.
2/4 is not greater than 2/3. Guys, look at it. Look at the picture. Do not get fooled by the number. Look at the picture. The top one has 4 parts. The bottom one has 3. Which one has more shading? 2/3 has more shading. 2/3 is the greater number. Plus, here's another trick, guys. Here's another trick for this. Is 2 closer to 4 or is 2 closer to 3? Yeah. It's closer to 3, right? So in that case, you should know this one is the greater one because if I was to say to you, Talon, I've got this pizza. I always use pizza. I've got this pizza, and I cut it into 3 parts. I'm going to give you 2 of them. Or I have this other pizza, and I've cut it into 4 parts, and I'm going to give you 2 of them. Which one are you going to get more pizza? The 2/3, right? Because if I'm giving you 2 out of 3 parts, I'm giving you almost the entire thing. Does that make sense? This one, 2/4 is equivalent to 1/2. That'd be like me saying you can have half the pizza or you can have almost the entire thing. You'd probably choose the entire thing or almost the entire thing, right? Unless you don't like pizza, and then you probably wouldn't. But, you get what I'm saying? Sort of? Kind of? The 2 is closer to 3, which means that if I'm giving you 2 out of 3 parts, that's better than giving you 2 out of 4 parts. It's closer. Okay, closer to the whole. You can also look at it in terms of a number line. If we drew a number line out for this one, and we start at 0 here, we're starting at 1 and we're ending at 1, which is the whole. And the whole is 3/3. And I said we're going to land right here. That's pretty close to the end, isn't it? Pretty close. Go ahead. Okay, what about this last one, guys? 3/4 or 3/6? 3/4 or 3/6, brother? 3/4. That's right. Again, do not get fooled by the denominator. When the denominator is greater, guys, when the denominator is higher, it means you've got more parts. Your whole is cut into more parts. That means those parts are smaller. The more you cut something up, the smaller they get. Again, using the pizza, if I had a pizza and I cut the pizza into, one pizza was cut into just straight down the middle, half, right? 2 pieces. Those are going to be pretty big pieces. But if I had a pizza and I cut it into 8 slices, how big are those pieces going to be? They're going to be pretty small, right? Depends on how big the pizza is, but an 1/8 is always going to be smaller than a half. Right? Unless it's an 1/8 of a pizza that's like this big, and your half of the pizza is this big. In that case, get them. In that case, it's a little bit different. But that's the basic idea here. Now we actually have the circle. It worked better for my analogy. Teva. I hear way too much talking and I cannot hear Teva. You guys know what time recess is. Guys, shh, focus. Focus. Okay, it is not recess yet. We are not there. Jack. Can you get another pencil? Yes. Smith.
Two things. And the other one, I got everything correct.
Good.
And are these equivalent fractions?
These are not equivalent fractions. We're comparing fractions. Most of these are not going to be equivalent. And you would know if they were equivalent because they would look the same in the drawing. The shading would be the same. Right? To make some of these equivalent, you would have to do something like this one, for instance. You have to shade in this, and then it would be equivalent. But they are not equivalent. Delete that. And that one. Okay. What about this one, guys? Is 1/2 greater or 1/3? 1/2 or 1/3, Wilkins? 1/2. 1/2 is greater. You can see it in the picture, right? What about 2/6 and 2/3? 2/6 and 2/3. Anybody who has an answer? Anybody? Ariana? 2/3 is greater. You can see it in the picture. You can see it in the picture. Sellers.
Have you ever heard of?
Are you on the right page? You better turn over to it. Thank you. What about this one, Sellers? 3/4 or 1/4?
3/4.
3/4, exactly. Now that one's a little bit easier, right? Because it's a like denominator. So you know that 3 is greater than 1. What about 3/6 and 3/4? Andrew.
3/4.
That's right. Again, don't get fooled by the denominator. Look at the picture. 3/4 is greater. What about 2/4 and 2/3? 2/4 and 2/3. 2/4 and 2/3. Zoe. 2/4 and 2/3. Which one's greater? Do you have that page out in front of you? You should. Everybody should have this page out. Which one? 2/4 or 2/3?
2/4.
Are you sure about that? Look at the picture. Which one looks greater? Look at the shading. I hope you're checking all of yours.
Alright, 2/3, but I meant to put 2/3.
Okay. 2/3. That's right. Now what about 3/8 and 3/6? 3/8 and 3/6, Teva. 3/6. That's right. That's right. When in doubt, double check the picture. And if you don't have a picture in front of you, draw one. Draw one out. Draw out the fraction strips. They're easier than the circles because I see you guys dividing circles up in really weird ways. Use a fraction strip. It's easier. Heston. You want to play a game? We might have some time for that. But, hold on, guys. Okay, that's tomorrow. Do we have questions on any of the comparing? Comparing fractions. No questions on comparing fractions? Yes, questions. Sellers, question.
Have you ever heard of those giant pizzas that have like every topping on them?
Yes.
And they're like super big.
I've seen some very large ones. Guys, we are not calling out. Hester.
Once again, this is kindergarten.
Oh, is it? Apparently, though, the equivalent fractions are not, because a lot of you guys have trouble with the equivalent fractions. So, I will be doing more equivalent fractions. I should not hear talking. Please take a seat.
One, all your foods and analogies are making me hungry, and
My apologies.
2,
Bless me.
turns out there's actually a vending machine that dispenses pizza.
Yeah, you know there's some vending machines that dispense a whole lot of things these days.
Yeah, there's actually a vending machine that dispenses cars.
Yeah.
I've seen that.
Okay, guys, let's move on. Should I hear talking right now? Thank you. Schmidt.
Actually, I got every single one of those correct.
Good.
And I kind of really like food.
Good. I'm glad to hear that. Allie.
I got every single one right in first try.
Good. I'm glad to hear that. That's a good thing. Brewer.
I agree with that. All this is super easy.
Oh, yeah?
I love
So are you guys telling me the equivalent fractions are easy too?
it. Yeah.
Some of you think the equivalent fractions are easy. Some of you don't. So we need more work on the equivalent fractions. So on that note, actually, I think because we do need to work a little more on our equivalent fractions, I think that we should do some equivalent fractions Kahoot.
Nope.
So, yep, that's a yes. There is no negotiation here. Everybody get out to the computer.